Building a reliable, multi-threaded app in .NET can be a very complex task. Working with locks, events, and queues forces you to reason at a ridiculously low level of abstraction. And with so many small details to think about, the code no longer fits in your brain. As a consequence, users report random exceptions that are impossible to reproduce. With PostSharp Threading, you can address multi-threading at a higher level of abstraction with deterministic machine-verified threading models. Thanks to PostSharp, your code will be cleaner, you will avoid random errors, and you will get more time to focus on what matters. Here is a sample multi-threaded app. This is a multiplayer WPF game where the state can be changed either because of the UI, the timer, or the network. If two of these sources change the state at the same time, random errors may happen. Let's see how you make this app thread-safe with PostSharp Threading. The source code has 4 namespaces: the view model, the model, and the communication stack. Instead of reasoning about individual fields, you can take decisions about whole namespaces. For the view and the view model, the thread-affine model is a good choice. It means that only the UI thread will have access to these objects. Instead of applying the aspect to every single class, you can apply it on an interface, and it will automatically apply to all derived classes. Creatures are children objects of board view model, so you can mark it with the child attribute. Unlike the view, the model classes are accessed from both the UI thread and several background threads. Since the state of these objects is mutable, the reader-writer synchronized model is great for this namespace. It allows several readers at the same time, but writers get exclusive access. This model requires you to mark public methods as readers or writers. Let's now look at the communication namespace. The network client has no mutable state and can be marked as immutable. Of course, this class was already thread-safe before, but thanks to this aspect, you are now guaranteed to get a runtime exception if someone inadvertently adds some mutable state to this class. The same with the server-side session object. For some classes, the choice is not so simple. The board service class contains a mutable list of client sessions, which seems to call for a lock-based model, but it also performs I/O, so a lock-based approach would cause high thread contention. The best option here is to treat this class as 2 entities. Board service itself will be immutable, but the session list will be stored in a thread-safe dictionary. Run the app and see if it works. Oops! The thread access exception means that the timer thread is attempting to access the board object, but does not own the proper access right. This is because the onTimer method is missing a writer attribute. The exception is intentional and will only happen in your debug build. Without this exception, you would have overlooked the defect and risked random failures in production. But thanks to this exception, the problem has been made visible, and you're now forced to address it. That's what we mean by deterministic machine-verified threading models. There is another occurrence of this error in the onConnectionClosed handler of the thread-affine main window class. The handler is invoked from a background thread, so it would also throw a thread access exception. To force the method to execute on the UI thread, apply the dispatched aspect. Run the app again. Great! How can you know that you are done and that you didn't forget to assign any class to a threading model? You can add the thread safety policy to the project. It will check your code during the build and warn you about potentially unsafe classes and static fields. Oh, we forgot the random generator class. Make it a synchronized object. It never gets accessed concurrently. Instead of an array, use an immutable array wherever you can. It makes it easier to reason about your code. Build again to see if the warnings disappeared. Done! You can still do a few optimizations on this codebase. This code in onModelCollectionChanged can be replaced by a simple dispatched aspect. The app runs more smoothly if the communication stack processes events in the background. You can do that with the background aspect. Let's run the app again and check that everything works. Excellent! Thank you for watching this demo. Thanks to PostSharp Threading, you can make your multi-threaded application robust and reliable. By assigning deterministic threading models to your code, you can identify defects that would have otherwise stayed hidden and caused random failures in production. With PostSharp Threading, you can make architectural decisions at the level of class hierarchies or namespaces instead of individual fields, reducing by an order of magnitude the number of decisions to be taken. Trust the build process to enforce these decisions across your whole code base and stop worrying about multi-threading.